Hi, everybody, and welcome. I'm going to talk about geometric series again. There are three formulas that pertain to geometric series. Actually, there's four. You can use a recursive series. I didn't write it down. But the first one is the explicit formula that you can use to find the nth term. So if you're trying to find the 12th term or the 15th term, you can use this formula, as long as you know the first term and the common ratio. Second, this is used to find the common ratio, but it's when we're talking about two consecutive terms. The third is when we are trying to find the sum of the first n terms. Problem number 25 gives us the sixth term is 41 over 25, and the ninth term is 205. And then they ask us to find the 12th term. So first I need to find the common ratio, and then I need to find the 12th term. In a series, you have numbers starting at the first term, and then they continue going up. They're increasing. In a geometric series, you're multiplying as you increase by a common ratio. In an arithmetic sequence, you're adding a common difference. We know that the sixth term is 41 over 25, and we know that the ninth term is 205. So we're multiplying by something each time as we increase. And 41 over 25 to 205 is increasing, so it's going to be a number that's bigger than 1. Now, we could use the idea of finding the common ratio between the one term and the next term, but we're going to have to adjust it a little bit. We know that we have 205, and then we have 41 over 205, but that's for three terms. So if we divide this to get some number, we then split it in three to get the common ratio. Since we have a6 and a9, not say a8 and a9, or a6 and a7. You get the idea. 205 divided by 41 over 25 gives you 125. If you split that by 3, your common ratio is going to be 5. Using the formula that we have for an explicit formula, we now know what the common ratio is. However, we do not know what the first term is. You can take a shortcut and multiply 205 by 5, and 5 again, and 5 again to get your answer. Or you can calculate it using the formula. If you take the shortcut, you arrive at your answer. But let's work it out using the formula. We're going to use the formula that the nth term is equal to the first term times r to the n minus 1. Our nth term is going to be equal to a to the 1 times the common ratio of 5 to some n minus 1. Well, now we can pick an n that we know. We know that a6 is 41 over 25, and we know that a9 is 205. And I know most people don't really like to work with fractions, so we're going to use a9. That means that a9 is equal to a1, which we don't know, times 5 to the 9 minus 1. We have a value for a9, and we can do 9 minus 1. So we get 205 equals a to the 1 times 5 to the 8th power. Isolating to get a1 by itself, we divide by 5 to the 8th. And then 205 divided by 5 to the 8th power is going to give you 41 over 78,125. And my formula then is going to be a sub n equals 41 over 78,125 times the common ratio of 5 to the n minus 1. And this is generic, so we can use it to find any n. Using it to find the 12th n, we take 41 over 78,125 times 5 to the 12 minus 1, which equals 41 over 78,125. 5 to the 11th is a large number. Multiplying that by our a1, which was 41, divided by 78,125, gets us to our answer of 25,625.